Our last objective for the lesson is solving systems of equations. A system of equations is when you're given more than one equation and you are to find the intersection of all the functions, meaning the point or the points they have in common. You can solve a system by graphing, but today we're going to look at systems of linear equations and find the intersection points using substitution or elimination. Taking a look at example 1, I can see it's going to be easiest to use elimination by rewriting out the second equation so that the y's line up a little bit better, and then eliminate. So this will be 6x, this y will move over to the left, becoming a negative, and let's solve it. The y's waching cancel out, and when we add the 2 and the 6, we get 8x equals 16. Dividing both sides by 2, I get my x coordinate to be 2. I said dividing by 2, I meant dividing by 8 to get 2. And then run over here, and it doesn't matter which one you plug the 2 into to solve for y. I'll plug it in down here. So 6 times 2 equals 5 plus y. That gives me a 12 minus 5 equals y, and I get y to be 7. So the intersection point is 2, 7. Example 2. Doesn't look like substitution is going to be a good bet for this one. I could have used substitution, I suppose, for number 1. I'm going to go to elimination. I'm going to get my y's again to eliminate. Oh, you know what? Second glance, let's get my x's to eliminate. I'll multiply the top row through by a -4. And then that will give me a -12x minus 8y equals -16. Now the x's waching cancel out, and when I add up my y terms, I get a -13y, and oh, this is convenient, and another -13. So my y coordinate of my intersection point is 1. To get the x that goes with it, plug it in, doesn't matter where. I'm going to plug it into the top, so 3x plus 2 times 1 is 2 equals 4. 3x is 2, and I get an x coordinate of 2/3, giving me the ordered pair 2/3, 1.